Around 500,000 hectares of peatlands have been affected by erosion to some degree. These are shown on the map on the roof of the car in red. We are on our way to just one such area, where large-scale restoration and monitoring is ongoing at Balmoral Estate.
One of my research projects is to see if we can integrate data from the eddy covariance flux towers, like this one over here, with data from spatial mapping of peatlands across the whole of Scotland and the United Kingdom. So for example, in this site, one of our challenges is that while we have maps of where peatland erosion has happened, this doesn't generally take into account just how complex this terrain is. So you can see from my height here just how deep the erosion is. Gillian behind you here is mapping out exactly where the gullies are so that we can start to understand how large an area of bare peat there really is. Just as an illustration, peat is about half of it is pure carbon. So you can see here just how much erosion has taken place. You've lost 1.5 meters of peat across an area of about 5 meters by, oh goodness knows, 20 meters at least, just in this one gully. And there are literally hundreds of these around us. Satellite images will possibly give us a flat image, but that doesn't take into account the three-dimensional erosion in these areas.
Varia is going to introduce how we measure greenhouse gas emissions on such eroded areas with a flux tower.
As the air moves across the surface, it's a lot of friction between it and the ground, and it generates all these eddies. So there's lots of the air down here is rolling around quite quickly. So we need to measure the quick changes, rapid changes in concentration and wind that are causing the gases to either get deposited on the surface or released up. So how do we do that? Well, on the tower here, in the middle, right up at the top, we have that instrument with the little sort of black spider legs. That's a sonic anemometer, and that measures the rapid variations in wind speed that you get as these eddies roll around. And then just below that, there's a sort of white cup thing. That's our inlet, and the air is drawn in through that and gets pulled right the way back to that sort of white tubey-shaped thing with the hose coming off it. And that's our sensor head, and that's where we measure the carbon dioxide concentration. And that instrument works really quickly as well. So the two of them are measuring about 20 times per second, so it's quite rapid. And you put that information together, and you can tell how much carbon dioxide is either being released from the peat bog or getting deposited down into the peat and stored as carbon in the peat. So we have all this information and measurements, and all these go back into the box here, and this is where we store all the data. We need to get that data back to the lab. So in here, we have what you call a data logger. So all the signals from the various instruments come in here, all the 20 times per second, and all that's stored in here. And the logger also does some basic processing on it and gives us some average values and things. And we have a connection to the mobile phone network, and every now and again it sends the data back to the lab for us, or we can dial in and just check that everything's working okay. And because we are in a very remote location, we don't have mains power to keep all the instruments going. So over here we have some solar panels and a fuel cell, and the box at the bottom has batteries in it.
We will put all of these data together, the data from the eddy covariance flux towers, which tell us the emissions from one particular site, together with the maps that tell us where certain types of degradation have happened, and that will give us a figure for the total emissions of carbon from Scotland's peatlands in their degraded state. And then, of course, the crucial question is how much of a difference does restoration make? So that's why we're doing all of this work. Barry, how big an area do you think you're capturing around some of these towers?
That's probably up to about, well, on a really windy day you could be going out to about 1 kilometre or so. Most of the time it's probably about 300 metres, isn't it? 500 metres.